All right, section 2 is the second method of solving systems, and it is called the substitution method. Okay, we've learned how to substitute before. You get a value for x and you plug it in and you see what it equals, right? Well, this is the same process, but just one step more technical. Okay, and the reason we have other methods is because graphing has some drawbacks, doesn't it? So, a couple of the things that I have noticed that there are drawbacks. Graph paper. You definitely need it, right? If you're trying to estimate a graph and get an exact answer, that's not going to work. So you either need to have an app or a program or something that has detailed lines so that you can get the answer, or you're just guessing. And that's the second drawback is you are guessing sometimes. Sometimes you get lucky, but sometimes you don't get so lucky. And because you're guessing, you have to check. And sometimes that checking gets pretty rough because you have fractions, and fractions aren't really easy to substitute sometimes. I'm sure there are others, but these are the main ones, right? And if you can think of anything else, just add it to your notes. And the idea is graphing is great when you need a visual, when it works out nicely, when you get integer answers and don't have to guess. But there are a lot of times when that's not going to happen. So we need some options. So the substitution method, as it says here in this paragraph, works really well when you have a single variable on one side of one of the equations equal to something else. This side can be more complicated, and it will be, but this variable all by itself makes substitution very easy. Okay, now in your notes, you have all kinds of stuff over here, but I blanked it out so I could do it with you. Okay, so here's the process. We have these two equations that need to be solved simultaneously. Basically, we want to see where those two lines cross on the graph, right? It's going to be a point, or it'll be no solution or all numbers on the line. But this one is going to be a point. Okay, so what we're going to do, let me rewrite it a little bit bigger here. Okay, and I'll show you, but really quickly, this symbol is just one brace. Okay, I can't draw them very well, but it looks like that. Um, it usually is printed to show you that these two equations need to be worked together as a system. Okay, apparently whoever created these notes was not able to put that in, so it's not printed. It should be. Okay, but if they tell you it's a system and they give you two equations, then just solve them together, you know? If this isn't here, and if it doesn't say it's a system, then you don't know what to do with these two equations. It's kind of like directions telling you what to do next, you know? Okay, so how do we solve this now? Because we want to figure out where these two cross, they are going to be in the same place at the same time. Okay, this is not what it looks like, but let's say this is the black line. You know that that one's a horizontal line. So the answer is right there. So at this point, whatever it is, it's on both lines, right? So if I combine both lines together to get one equation and solve the one equation, that's what we're going to do. Okay, so we know that y equals 4. So I'm going to take this value and plug it in right there for y. So that becomes 4x add 5 times 4, and then that's equal to negative 20. And if you notice, now we only have one variable, and we can solve for x. So you go through the process, solve for x, and that becomes the x value of your point right here. Once you figure out what x is, we can then figure out why. Okay, so let's go ahead and do this. First thing we need to do is multiply these two, right? So 4x add 20 equals negative 20. And now we're going to subtract 20 from both sides. We want to get the variable term by itself. So 4x equals negative 40. Divide by the coefficient. And we end up with x equals negative 10. So that tells us that the x value of the point that we're looking for is negative 10. Now we need to deal with the y value. Because this one already said y equals 4, we know it. So that is 4. And you're done. That point is where those two lines cross. Okay, now I'm going to check it just to show you. Okay, so check into 4 times negative 10, the first equation, sorry. 5 times 4 equals negative 20. We want to see if this is true. So we get negative 40 add 20. Sure enough, it is negative 20. That's true. Okay, I don't need to plug it into this one because I know that y is 4. So 4 equals 4. Yeah, that one's absolutely true. Okay, let's do one a little bit harder. Okay, so see here you have all of the explanation, but I'm going to blank it out and do it with you. Okay, so these are two equations taken together, solved as a system. And the blue equation this time is a little bit more complicated, right? Okay, however, one variable is by itself on one side of the equation. So this will work very easily. Okay, now this time, I'm going to take all of this and substitute it in here for y, because that's what y is equal to. Okay, so I'm going to take the first equation, because that's what I'm substituting into, and all of y, which is 3x minus 9, has to be times by the 5, like it was here. 5 times y, but y is all of this. So there we go. And that's equal to negative 11. We're down to only one variable, just x. So now we're going to solve it for x. So let's distribute here. 2x add 15x minus 45 equals negative 11. Now we have like terms. So 17x minus 45 equals negative 11. Get rid of the extras here so we can get the variable term by itself. So these cancel and we get 17x equals 34. Divide by the coefficient and we have found x, which is 2. Okay, so if our answer is a point on a graph, we just found the x value. How do you find the y value now? We are going to substitute again. Okay, so you can take x, so 2, and put it in either this equation or this equation for x and solve it for y. The blue equation is going to be the easier one because it's already solved for y. But I'll do both of them just to show you. Okay, so y equals 3 times whatever x is minus 9, but we know that x is 2. Okay, so y equals 6 minus 9, so y equals negative 3. There's your point. Okay, let me show you in the black equation instead of the blue one. Okay, so I'm going to do it just underneath here. 2x add 5y equals negative 11, but x is 2, right? From this. Add 5y equals negative 11. So 4 add 5y equals negative 11. So you can see how the blue one's easier, right? Because it's already solved for y. But if you keep going, you will get the same answer if you do your math right. So y is negative 3, y is negative 3. Okay? Now, how do I know that that's the answer? You technically should check it in both equations. Okay? We talked about it in the previous video, and again, this is not what the graphs look like. So there's the black line, there's the blue line. If it's true in both equations, then your point, that's your answer, is in between the two. It's where they cross. If it's only true for the black one but not for the blue one, then it's a point on one line and not on the other. If it's true in the blue one but not on the black one, it's not where they cross either because it's only on one line. It has to be true in both. And I just did it there in green so that you could see it. Both equations. So this is your 2x plus 5y equals negative 11. This is the blue one, y equals 3x minus 9. They're both true. So that means this is on both lines, and it's where they cross. Okay, now remember that isn't what this looks like. I'm just grabbing two lines randomly. But that's your process. Okay, let's do another one. Well, actually, we're on to you doing them by yourself. So first, let me show you. These are the steps that I use to explain what to do next. And if you notice, solve, substitute, solve is just opposite all the way down. So, and then you write your answer as a point. So I'm going to go back to the one we just did and show you how this works, starting with solve. Solve one equation for one variable. Okay, so here's my original. Solve one equation for one variable. That step was done for me. So solve that one. Now I'm going to substitute. So I put this into there, rewrite it. Okay, so there I substituted right there. Now I'm going to solve it for x. And that's what I finished out here. Then you substitute again, and you get your answer. So we're solving, right? And then there's your point. Okay, so solve, substitute, solve, point. Okay, so if you follow those steps all the time, you'll be fine. All right, so you have these two and those three. So try all 5 of those and then come back. Okay, this first one already has step 1 done for you as well, right? First step is to solve one equation for one variable, and that's already done because our first equation is already x equals. Okay, this one may have confused you a little bit because it was on the top instead of the bottom, or because it was an x instead of a y, but the process is still the same. Okay, so if x equals all of this, we're going to take all of that and put it in there for x. Okay, let me change that. There, that's better. So I'm going to take the second equation, put 2y minus 4 in for x, and keep writing the rest of the equation. Now I have one equation with one variable and I can solve it. So distribute 6y minus 12, add 4y equals -2. Combine like terms. So we get 10y minus 12 equals -2. Add 12 to both sides to get the variable term alone. So 10y equals 10. Divide by 10 to get the variable alone, and we get y equals 1. So we did solve, already done, substitute, solve. So our next step is to substitute again. So we're going to put this value into either equation. If you have one that's already solved for one variable, use that one because it's easier. But you don't have to, okay? I'm going to box this so we don't lose it in all of my crazy. Okay, so I'm going to rewrite the first one over here. And I'm going to substitute y equals 1 into it. So 2 times 1. Is that going to throw you off? With the red? Because this was the red solved part, right? Okay, minus 4. So x equals 2 minus 4. X equals -2. Please don't stop there. You've got to write it as a point. And the point is always alphabetical, so x always comes first. And what that means is that the point -2, 1 is on both lines. So it should check in both lines. And it does. Okay? That green part is not necessary. However, if you do something that doesn't feel quite right and you wonder if your answer is correct, at least do it in your head, you know? Okay, second one. Again, the first step, the solve for one variable step, is done. So we're going to take this 2x and put it in here for y. Okay? I'm going to box my original again so that we don't lose it. You won't lose yours, but I might lose mine. Okay, so we're going to take this part, put it in there for y. So we have 7x minus y, which is, now I usually put it in parentheses whether I need them or not. It just tells me it's been substituted. It's just my own trigger, flag, something, you know, whatever you want to call it, that tells me I've substituted. You don't have to. In this case, there's no reason for it because we're not distributing. Okay? Combine like terms. So we get 5x equals -15. Divide by 5, and I get x equals -3. Okay? Solve, substitute, solve. So now I substitute. Okay, I always run out of space going straight down, so I do the first one here and the second one here, but you can continue down the page if you want. So, where am I going to substitute? I could put -3 here for x, solve this for y, but this one's already solved for y. So that's the one I'm going to use. So y equals 2x. So y equals 2 times x, which is -3. So y equals -6. Writing it as a point is -3, -6. And there's my check, just so you can see it. But that is our correct answer. Okay? All right, here's our next three. So this one got a little crazier, didn't it? Okay, this would be one that we could solve by graphing. But can you imagine doing that? The reason I say that is because these are both in y equals mx plus b format. Okay, start at negative 13 and then go down 3 into the right 2. Huge graph, right? Here you're starting at positive 45 and then you're going up 10 and over 3. That's just crazy. So there's no reason you'd want to. So let's use substitution. When they are both equal to a variable, solo, you take this one and put it in there, or this one and put it in there. It doesn't matter. Okay? I have a tendency of doing the second one into the first, but it doesn't matter. Okay, so I'm going to put it in this way, and I end up with 10 over 3x add 45 equals negative 3 halves x minus 13. If you did it the other way, then these two would just be reversed. Now you need to deal with the fractions one way or the other. Either continue working with them or get rid of them. I'm going to choose to get rid of them because you've already been taught how to do that. I'm going to times everything by 6. Now this is why we learned the things we learned in chapter 1, right? Okay. 3 goes into 6 twice. 2 goes into 6 3 times. You could have used a 2 and a 3, which equals 6. That's why I chose 6. Okay, let's see what we have left. 2 times 10 times x is 20x plus 6 times 45 is 270 equals 3 times negative 3 is negative 9x minus 6 times 13 is 78. Yeah, a little crazier. So I'm going to get the variable on one side. So now I have 29x add 270 equals negative 78. This is just crazy. Minus 270. And I get 29x equals negative 348. And thank goodness it goes in evenly. Okay, and I'm going to put the answer off to the side because I've run out of space. So x equals negative 12. It's like, whew, thank goodness, right? Okay, now when I put it back into one of the equations, so they're already solved, we've substituted, now we've solved, so now I need to substitute this into either of these. I'm going to choose the first one just because the numbers are smaller, but it doesn't matter. Okay, so I'm going to do y equals negative 3 halves x minus 13. So y equals negative 3 halves times x, which was negative 12, and then minus 13. So I can cancel. 2 goes into 12 6 times. So I have y equals negative 3 times negative 6 is positive 18 minus 13. So y equals 5. And the point is 5 negative 12. And sorry for that little jiggle and changing everything on you, but no, it's not 5 negative 12, is it? It is negative 12, 5. Alphabetical order, like we've talked about, x first, y second. And the reason why I figured that out is because I did this green stuff to show you that they checked and they didn't check. So I had to backtrack, figure out what I did wrong, and I recognized that I had reversed these. Okay, so I straightened it out, plugged them in correctly, and they both worked. Okay, so definitely a good reason to check your stuff. Okay, all right, let's take a look at number 4. And it got a little bit harder, didn't it? The reason why it's harder is because you don't have an equation already solved for one variable. So you have to do that yourself. So far, that step 1 has already been done, but now you need to do it. Okay, so what you need to look for is which of these variables is going to be the easiest to solve for. That one right there, because it's already by itself. There's no coefficient. Okay, so the only thing we need to do is move this 6y to the other side, and it will be x equals, right? Okay, so if I, I'm trying to change things and it's not working. If I were to just subtract 6y from both sides, and I'm going to rewrite x equals, because this is gone, negative 15 minus 6y, or negative 6y minus 15, it doesn't matter. You don't need it in any particular format because it's not going to be slope-intercept form or anything. We're going to substitute. Okay, so now just to make it make sense for you, this is what I like to do. This is equation A. This is equation B. So this is my new equation A, but it's still A, right? It's the top one. Okay, now I'm going to take A and put it into B. So this is my solve step, because it's x equals now. This is my substitute step. Okay, so I'm going to write B again. 4x minus 6y equals 0. But x is what we just did. So since I did it in red up top, I'm going to substitute in red. So 15 minus 6y, parenthesis, minus 6y equals 0. Okay, so now I need to distribute. So now we're going to distribute. We get negative 60 and negative 24y. Minus 6y equals 0. Okay, so combine like terms, right? So these two, and we get negative 60 minus 30y equals 0. And I'm going to run out of space. So add 60, and I'm going to take the answer up here. So these 60s cancel, and I get negative 30y equals 60. Divide by negative 30, and I get y equals negative 2. Okay, so solve, substitute, solve. Now I need to substitute, right? Okay, so I'm going to take y equals negative 2, and I need to plug it into an equation that has both variables. Okay, so any equation that has both variables, we could use the first one, A, we could use the second one, B, or we can use this one where we solved for x. Because now if I substitute y in for y, all I have to do is simplify this side and I get x. So this is the one I'm going to choose to substitute it into. That's the one that I'm going to write next so that I can substitute. Okay. X equals negative 15 minus 6 times the negative 2 that we just got. So x equals negative 15 add 12 So x is negative 3. And the point becomes x value first, y value second, and I'm definitely going to check it now. And it worked. Thank goodness. And here's the last one of those group problems. So this one doesn't have anything easy to solve for, does it? Every one of the variables has a coefficient. So you just need to kind of figure out which one would be easiest to solve for. Okay, so for example, if I wanted to solve for this or this x of that equation, I would have to move the 3y over here and then divide by 6, right? So 18, so yeah, 18 divided by 6 is fine, but I'm going to be dividing the 3 by 6 and I'm going to get a fraction. Okay, so what you need to do is kind of that process is if I want this x to be what I solve for, I will eventually have to divide by negative 5. So if I divide this by negative 5, I get 3/5. I don't want a fraction if I don't have to. Okay, so what if I solve this one for y instead? I divide by 3. I get 5/3 and I get 5. I still have a fraction. So what if I divide this one for y? I'm going to divide by 3. 6 divided by 3 is 2. 18 divided by 3 is 6. And that worked. Okay, so that's where I'm going to start. I want to solve for that y in that equation. Now you've been taught how to use fractions and how to get rid of fractions, so if they don't scare you, then yeah, you could do whichever one you want. But this is the easiest one because it doesn't have any fractions. Okay, so let's solve the first one, equation A for y. Okay, so A, 6x plus 3y equals 18. And solving it for y. There we go. Okay, minus 6x minus 6x, and we get 3y equals, and I'm just going to leave it in this order, it doesn't matter, 18 minus 6y. Now I want to divide by 3 all the way across. Okay, so these 3's cancel. I get y equals 6 minus 2x. Okay, so in our series of steps, solve, substitute, solve, we've solved. Now I need to substitute. Since this was A, I am going to put it into B. Okay, so substitute it into B. I'm going to write B over here just so I have it. And now I'm going to put that whole thing here in here for y. Okay, so I end up with negative 5x minus 3 times y, and y is 6 minus 2x equals negative 15. Okay, so now we're going to distribute here. So we end up with negative 5x minus 18 add 6, because it's a negative 3 and a negative 2 makes a positive 6, equals negative 15. Combine like terms. So I get 1x minus 18 equals negative 15. Add 18 to both sides, and I end up with x equals 3. Okay, so solve, substitute, solve. So now I'm going to substitute our x value into any equation that has both variables, right? So I have this one, I have this one, and I have this one. That's the one I'm going to use. Okay, if you want to call that equation C, you can do that. But I am going to plug it into, actually, yeah, let's do that. I'll call this new, or how about A prime? There you go, because it was A, and then I reordered it, so it's A prime. I like that. Okay, so I'm going to plug our x value into A prime. A prime is y equals 6 minus 2x, and I'm going to put the 3 in there. Okay, I'm going to do the same thing with this one. There we go. So y equals 6 minus 2 times x, which is 3. So I get y equals 6 minus 6, so y is 0. Alphabetical order, 3, 0. And just to be absolutely safe, let's check it. And it works. Okay, so 3, 0 is my one point that is on both lines. It's where the two lines intersect. And how did you do? Hopefully did okay. All right, now let's see what happens with those last two possibilities, those special cases, right? Okay, so it says solve by substitution. You can solve other ways, but we're just learning substitution here, okay? So let's see what happens. This first one is already solved for y in the second equation. So I'm going to take this y equals stuff and put it in here for y. So let me zoom in a little bit too. All right, so whoops, we have a and b, and I'm going to substitute b into a. It's already ready to go. So b is y equals, so I'm going to replace y with all of the second stuff that's equal to y. Whoops, black there. And I'm going to say it's equal to 5 because that's part of a, right? So 4x add 2y equals 5. So solve, substitute. Now let's solve. So we get 4x minus 4x add 2, because I'm distributing here, right, equals 5. Your 4x's cancel out, so we end up with 2 equals 5, which is false. Okay, and if you remember from way back in chapter 1, when we're solving equations, and we had variables on both sides and all this crazy stuff, if the variable cancels out and what you have left is false, there is no number that will work. Okay, so the variable canceled completely out, and what we had remaining was false. So that means in this particular case, there is no solution. So if I have no solution for x, then there's no way I'm going to get a solution for y. I don't have a value to plug in for x to compute and see what y is. Okay, so you don't continue. You're done. As soon as you get something false, you can stop. Okay, so that means for the entire system, there is no solution. Oops, let's do it in black. Okay, and if you remember back to what we learned in the graphing section, no solution to the system means what? If we're looking for where the two lines cross, here's one line, and again, these do not match the equations. The other line that cannot ever cross it is going to be parallel. Okay, so you don't need this as part of your answer, so the lines are parallel and will never cross. Okay, so this part is not part of your solution. It's just I'm adding it in so that you can understand. Okay? All right, let's take a look at the other one. So solve the system by substitution. Oh, that's nothing new, right? Substitution, sorry. It already has y equal to this. So we're going to take all of this information, put it in here for y. So equation A, equation B, we're going to take B and put it into A. So we end up with 6x minus 2 times whatever y is, which is 3x minus 2. And now that's equal to 4. Okay, 6x minus 2y minus 4. All right, let's distribute here. And we get, whoops, 6x minus 6x add 4 equals 4. 6x minus 6x cancels out. But now this time, what we have left is true. Okay, so if the variable cancels completely out and the remaining information is true, then any number is a solution. Remember, all real numbers. Anything I put in here, because I put in 92 and I put in a 92, they will eventually cancel out. And what you will be left with is going to be true. Okay, so if any number works for x, then that means I have an infinite number of x's possible, which therefore means I have an infinite number of y's as well. But they need to be specific to these lines. So this tells me that those are the same line because there is an infinite number. Okay, so if that's one line, the other line is right on top of it. Pretend I made it. Okay, let me do a different color. Right here, right on top of it. Okay, so because they are the same line, there's an infinite number of points that they have in common. And the way that you write that is in set builder notation is one answer. Okay, so that would be the set of all points such that, and then choose an equation. I'm going to use B because in my mind that's the simpler of the two. You don't want to make your answers more complicated. You want to make them as simplified as possible. Or you could say all points on and then write the equation. Okay, this is the way that Canvas is going to have you write it, but the only thing you really need to enter is this part because they have the rest filled in. When you get to your exam, I don't care which version you write, as long as you tell me that it's all points specifically on the line. It can't just be infinite because there's an infinite number of answers. It has to be specifically the points on the line because they are both the same line. Okay? Now here's your two. See what you can do with those. Most likely one will be each kind, right? One will be one and one will be the other. Problem number 1 is already ready to go. So we're going to take, whoops, hang on. Technical difficulties there, sorry. So we're going to take this one because it's already solved for x. We're going to take all of this information and put it in for x. Okay, so I'm not going to worry about A and B this time. So 2 times all of the bottom, because that's x. So 2x, 2x. Add 6y equals -8. Solve it for y. Okay, so here we go. -6y minus 8. Add 6y equals -8. The 6y's cancel. And maybe you already know by now which one it is, but you're asked to show all of your work or enough work to prove that it's yours or the answer is yours and that you did all of the work. So don't stop too soon, you know? Okay, what we have left is true. So because it's true, that means any answer works for y. So an infinite number of answers means you're going to have every point, which is an infinite number of them, on this line. Or the other line. Doesn't matter. Choose one. Okay, number 2. This one isn't solved for anything, right? So I'm going to look through there and figure out which one would be easy to solve for. And I see x over here without a coefficient. So I would subtract 3y over here to get x by itself. Let's say it did have a coefficient, okay? And I have to look at the other equation. I would solve for x here would be next best because I have to divide by 4. This gives me a whole number, and this would give me a whole number. Okay? If I divided by 12, I'd get a fraction, and I'd get a fraction. If I divided here by 3, I would get a whole number, but here I get a fraction. Okay? All right, so I'm going to solve for x right there. So down here at the bottom, I'm going to rewrite it. And minus 3y from both sides. So those cancel, and I get x equals 12 minus 3y. So now I'm going to put that into the second equation. So minus 12y is equal to -40 add 4 times all of x, which is 12 minus 3y. And now I have to distribute here. So I get -12y is equal to -40 add 48 minus 12y. Okay, you've got multiple steps you could do next. I'm going to combine like terms. So we have this one and this one gives me -12y equals 8 minus 12y. Now add 12y to both sides. Whoops, not 2, 12. There we go. Add 12y, and I'm going to slide it up just a little bit. So these cancel, equals 8, and these cancel. You can't have an entire side cancel completely out. So what goes here? A 0. And this is false. Okay, so since it's false, there is no solution. You can write it this way. You can write actually no solution. You can say no answer. You can say, what else? DNE. But the idea is they don't cross. They will never cross. So you never have a solution. That means these two lines are parallel. And because this has an infinite number of solutions, they are the same line. Okay, now that red part's a little bit extra, but I just want you to understand what's happening, okay? So rather than just doing the math, I want you to be comfortable doing the math. So we've got the special cases there. So that information here to give you no solution, information here gives you an infinite number of solutions, but this is your answer. Okay? Alrighty, guys. Good luck. You got this. And let me know what questions you have, okay?